Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Find the student that will replace the chalk. Leetcode 1894. In this problem, we are given n students in class, numbered from 0 to n minus 1. The teacher will give the student a problem starting with student number 0, then the student number 1, and so on until the teacher reaches the student number n minus 1. After that, the teacher will restart the process starting with student number 0 again. Then we are given a zero index integer array chalk and an integer k. There are initially k pieces of chalk. When the student number I is given the problem to solve, they will use chalk I pieces of chalk to solve the problem. However, if the current number of chalk pieces is strictly less than chalk I, then the student number I will be asked to replace the chalk. Then we have to return the index of the student that will replace the chalk pieces. Then in example 1, we are given chalk array as 515. Meaning the first student uses 5 pieces of chalk, the second student uses 1 piece of chalk, and the third student uses 5 pieces of chalk again. And we are given k equal to 22. Now, student number 0 uses 5 chalks, so we will have 17 chalks remaining. Then, student number 1 uses 1 chalk, so we will have 16 chalks remaining. Then, student number 2 uses 5 chalks, so we will have 11 chalks remaining. Then student number 0 again uses 5 chalks. So we will have 6 chalks remaining. Then student number 1 uses 1 chalk again. So that we will have 5 chalks remaining. And finally student number 2 uses 5 chalk. Then we have no chalk remaining, right? So now student number 0 has to go and replace the chalk. So that's why we will return 0 as an answer. Now if you see, we are going through the chalk array again and again in cycles. So for example, first we went through this cycle, then we again went through this cycle, and then we are reducing the value of k, right? And eventually there is a shortage of chalk. For example, student 0 needed 5 chalk, but there were 0 chalks remaining. So that student will go and replace the chalk. So what we can do is we can actually calculate the total chalk usage in one complete round. For example, in this case, it will be 5 plus 1 plus 5, that is 11. And then we can determine how many full cycles we can make with the given chalk so that we can avoid those cycles. So number of cycles will be k divided by total usage. So for example, in this case, we had 22 divided by 11, that is 2 cycles. But like I said, we don't care about the number of cycles. We just want to avoid those cycles, right? So what we care about is chalk remaining after running all the cycles. And that is equal to k modulo t, which will give us a remainder. And in this example, k is 22, t is 11. So when we do k modulo t, we will get 0. So that means we had 0 chalks remaining after running 2 complete cycles. So in this case, the first student, that is the student at index 0, will need to replace the chalk. So this helps us strip down the problem to a simpler scenario where we only need to consider the remaining chalks after the full cycles, because here we are doing the subtraction and that is taking a lot of time. But instead of that, we can actually do the modulo operator and that will give us the remainder way faster than subtraction. Now let's look at example 2 as well. Here we are given chalk as 3, 4, 1, 2. So the total chalk usage in one round will be 3 plus 4 plus 1 plus 2. So that is 10. And k is given as 25. So again, this whole subtraction cycle will run for 2 cycles, right? But we don't care about number of cycles. We care about what is the chalk remaining after those cycles. So it will be k modulo t, which will be 5 in this case. And now we again start the cycle. So first student uses 3 chalks, so only 2 chalks will be remaining. And then we come to student 1. So student 1 needs 4 pieces, but we only have 2 left, right? So student 1 will need to replace the chalk. And that's why we will return 1 as the output. So to summarize, we will make complete rounds. It can be 0 as well, but the idea is like we do the complete round and at the last round, any student with a chalk shortage will replace the chalk. So we save time by using the modulo operator instead of subtracting each time. Now let's jump into the code part. So first thing we will do is calculate the total chalk usage in one round, and we can use a long to store that sum, because if you see, number of elements in chalk array can be up till 10 to the power of 5, and individual chalk value can also be equal to 10 to the power of 5. So we can actually get an overflow. So better thing is to use long here. Now we will just loop over the chalk array and sum it up. We can also use Java streams to sum it up as well. Now what will be the chalk remaining after the full rounds? It will be K modulo T, right? That is K modulo total usage. And now we will start our cycle of subtraction basically. So at any point, if remaining chalk is less than chalk requirement for the highest student, we will return that index. Otherwise, we will just subtract the chalk used by that student. That's it. And in the end, we will just return -1. Otherwise, our compiler will give the error. But if the test cases are correct, we will return it from the for loop itself. Now let's run this code. I should be using remaining chalk. Sorry about that. Now let's run this code. Cool. Let's submit this code. Awesome. In terms of time complexity, it is O of n, where n is the length of the chalk array because we are just looping over this array once. And in terms of space complexity, we are not using any extra space, so it will be O of 1. I hope this video was useful to you. If you have any questions or suggestions, please write it in the comments below. The code link is in the description below. Don't forget to like, share and subscribe. Have a nice time. Thank you.